This is a 2008 Yukon Denali, the 1500 series, all-wheel drive, and it has a problem with a thumping noise in this driver's front wheel on turns. The wheel bearing's bad, so I'm going to be changing the wheel bearing in it. First thing I'm going to do is go underneath the vehicle behind the driver's front wheel and either set a jack on this lower control arm and raise it up and place a jack stand on the frame. Heavy part here where it's seamed. Or I can jack it up by the frame, put a jack stand under the control arm, or jack it up by the hinge point on the cross member. I've got a jack stand sitting on the thicker part of the control arm, and I'll just leave the jack underneath the cross member to support it a little extra. I'm going to go ahead and take the lug nuts and wheel off. They're 22 millimeters. 6 lug. I left a few lug nuts loose on there so I can kick the wheel, make sure it's going to come loose. It's not stuck or anything, so I'm in business. If it would happen to be stuck, you can just break all the 6 lug nuts just a quarter turn loose, and then back it up, pull it forward, and stomp on the brakes to get the wheel loosened up on there. Then jack it up and take the wheel off accordingly. Same with the rotor if it gets jammed because of oxidation from the aluminum wheels to the center hub part. And that's a jewel. The new wheel bearing I'm using to replace this with is coming with an ABS sensor and a cable. So I just take a pair of needle nose and pry all these clamps out of the brackets. If you get a wheel bearing that doesn't have this sensor stuck in the side of it, then just take this 10 millimeter loose and unbolt it out of the wheel bearing and get to it, get that shield off. But I'll just push down on this retainer in the back and unplug it. Try not to pull on the wires themselves. I set a multimeter to ohms. The new wheel bearing has an ABS sensor on it, and I ohmed the 2 pins down in there. At about 59 degrees, it's reading just below 2,000 ohms. So I'm going to check the vehicle's original one, make sure they're close. Temperatures are about the same. Temperature matters on the resistance of the windings in this sensor. And I'm going to go ahead and ohm this one while it's the same temperature as the other one. And they was within 0.03 of an ohm the same, so the new wheel bearing sensor is good. And the next thing I want to do is stick a punch into these rotor fins on the bottom side and take this axle nut loose. If you're using a ratchet manual, I'm going to just impact this one off because the wheel bearing's damaged anyway. The impact can damage the wheel bearing, and this one's already ruined, so I'm just going to impact it off. An 1 3/8 socket accommodates it. We're 36 millimeters kind of loose on it. It has a washer back in there, so don't lose that. supposed to have a new nut installed from the factory, but I can get around that, I guess. I'll take a hammer and punch and dislodge the axle shaft back in there about 1/4 of an inch just to get it moving. Be sure not to do anything to damage the rubber boots, or the axle joint will go bad from loss of grease. We'll get in between this slot and the caliper and pry outward on the caliper to loosen the pads up on the rotor. Just to get a little slack in them so they'll slip off, especially if there's a ridge worn into it. And then take an 18mm, two 18mm bolts out of the caliper hanger, and then hang the caliper assembly by either wire or bungee cord off the spring up here. You don't want this hose getting very much stress put on it. It'll damage it internally, possibly causing brake problems. I've turned the steering wheel a little bit to the right to give me a little clearance to get an impact in there and get those caliper hanger bolts off. The wheel bearing bolts are the 15mm. The smaller ones in a triangle position. There's two, one at the bottom, one at the top, and one in the front. And they actually hold the wheel bearing on. That's 3. This is an excellent time to determine whether you need new brake pads or not by the thickness of the black material on the metal backing, and both sides are wearing evenly, and the slide pins aren't hung up, and the condition of the rotor's been a little hot, but it's not warped yet, so, or it doesn't have any run out. But they look pretty good. If there is a rotor retaining bolt, it's a T27, an odd one, between a 20 and 30. And take it loose. I suppose you could catch a bad wedge on the side and get it loose without one, but it'll damage it. And the rotor should be ready to slide right off of there. At any time, feel free to take a drill brush and clean all of the loose scale from inside this rotor if you're reusing it and not installing new ones. And here's the hub flange, the backsplash shield, and the ABS sensor. Now there's 3 15mm bolts. That's got to be taken loose in a triangular pattern around this axle shaft. And I'm going to go ahead and take those out. They're pretty big boys too. Yeah, while you're in here, look at the general condition of your tie rod ends and ball joints, that their rubber's not blown out on them, and that the wheel's not moving on its own somewhere in one of them. As I say, be sure no sharp edges touch this rubber boot or damage the CVC joint will occur long term. Feel free to turn the steering wheel left or right to get access to the rear and or the top bolt. Turn the steering wheel to the left to get to the front one. Once you get these 3 wheel bearing bolts out, feel free to wire brush them off some, clean them and dry them off some brake cleaner. Shouldn't be any lubricant on them. And you can saturate this triangular seam that the wheel bearing's sitting against the spindle with penetrating oil, both from behind and the front. Let it set for a while, depending on how hard it's going to be to come off. I usually test it with a hammer, see how bad it's going to be. Be sure not to hit your backsplash shield and damage it. This one's kind of rusty. It wouldn't take much to ruin it completely. I'll just tap around on it and see if it's going to come loose. And if not, I'll spray some lubricating oil around it. Its perimeter. Once it starts breaking free, you'll see a gap opening up between this splash shield and the spindle, and probably some shiny metal done in there. As it starts pulling away from the spindle, take a punch. Be sure not to hit it face on or you'll damage the threads and not be able to get the nut back on without either grinding the end off or cutting it off. And knock the axle back the same distance as pulling away from here. Once it starts moving, it should slip on out of the wheel bearing. At least for the amateurs. Okay, it's pretty much free. I'll pull out on the wheel bearing, it's not too bad. And I'm not hitting it too hard, so it's not bending it up too much. Be sure and pay attention to the orientation of your splash shield. It's got a slot that lines up with the ABS sensor, and then the straightaways with the brake caliper hanger. And it kind of curves back. So if this is facing out, and the ears are curved back toward the caliper hanger. This wheel bearing is kind of heavy, so watch it come off of there. There's a back splash shield, slot for the ABS. And you can take a wire brush and make sure that it's scab free around the mounting surface of the wheel bearing on both sides. Something scrape the high places off. And take a wire brush to these splines on this axle shaft. I'll probably go ahead and turn the steering wheel so it's pointing straight ahead. And then I got to scrape the inside of this spindle out where the new wheel bearing will set, or it won't get back in all that crud. So I've got a little bit of time to waste here. I'm going to go ahead and start cleaning this area up and all these splines so it'll slide to the new wheel bearing without incident. And this backsplash shield. Be advised while cleaning this that it does have brake dust, which is hazardous to your health on it, and you should be wearing a dust mask. I took a fine screwdriver and went through all these splines and pushed the excess lubricant. It was like axle grease had turned into wax, and clean all those splines with a wire brush after chasing them with a skinny screwdriver. And scrape this out so the new wheel bearing will slide in there. And this surface is flat, especially where the bolts pass through, and a triangle is the stress points here, here, and here, but it's flat all the way around. Clean the back cover, and finally hit it with some brake cleaner and dried it up with a shop towel. Now I'm going to apply a light coat of grease to the inside of this spindle, and just a light coat on these splines, not the threads, just the splines. I've cleaned this face off this axle, scraped it off where it sits flat against the wheel bearing. I don't see any problems so far. thin coat of grease is applied to the splines and to the inside of this. I didn't get any on the face or this plate or on these threads. They're dry. I'll slip the new wheel bearing on there. I kind of hit this all over the face. I don't want any rust particles falling down in behind this flat surface. Feel free to spray paint that back splash shield if you wanted to. Lay the splash shield down on the wheel bearing and pull the ABS wire through this slot with the turns facing the spindle, raised up edges. Should look like this. These facing in. ABS slot accommodating the wire. And I'll pick the whole assembly up with this flat area in line with the brake caliper hanger area and the ABS sensor pointing forward above the tie rod end. And put the 3 cleaned bolts back into the wheel bearing. And when I'm holding the wheel bearing, grab the boot back here and make sure the axle passes at least 2/3 of the way through it. If it doesn't, sometimes you can rotate the wheel bearing and kind of find a sweet spot in it where it'll slide on better. But usually it's because the splines aren't cleaned off properly and they may need cleaned. When you slide it back, don't get your ABS wire caught between the tie rod end and the spindle leg there. Make sure it's up 11 o'clock, directly in line with the splash shield opening. And the axle's passed through a pretty good piece. It slid through easily, so there's no problems showing up there. Now I'll stick the bolts in it. I've got all 3 hub bolts tightened down to about 30 foot-pounds. Their final torque is going to be 133 foot-pounds. Make sure the hub flange face is clean and dry, and that the rotor surface is flat, relatively rust-free, and no debris on it. We're going to bounce it against a piece of wood, knock any loose pieces off. You don't want any pieces getting between this flat surfaces of the rotor and the hub flange, or when you hit the brakes, the rotor will be flopping around, and or also the wheel. Just gotta slip it on the studs and line one of these beveled holes up, not the threaded one. If you've got the Torx bit, it goes in there, and tighten the rotor back down to a threaded hole on the hub flange. Slide it on real easy and be sure not to knock any debris down behind it. Tighten it down to about 12 foot-pounds. Be sure this rotor face has the scale knocked off of it, so there's nothing sticking up per se, especially around the center. If you had a problem getting your wheel off, you could put a light haze of grease around this center hub that centers the wheel to help slow down the transition of aluminum oxides to the steel. I'm going to go ahead and slip this brake caliper and hanger back on and install the 2 18mm bolts into it. They tighten down to 148 foot-pounds. Make sure your brake hose is curved around the upper control arm and not twisted in a knot, or you're going to end up with problems. I'm going to go ahead and start fastening the ABS wire back into its holders and lock it back together, plug it in. Make sure your splash shield isn't touching the rotor anywhere. and make sure none of the cables isn't in line with the rim, and that your rubber hose isn't knotted up, or you'll have problems. If took caliper bolts loose, they tighten to 74 foot-pounds. I'm going to put the axle nut back on. It tightens down to 177 foot-pounds. Do not use an impact to put it on, or you can damage the wheel bearing. I'll stick a punch in the rotor to hold it while I tighten this down to 177 foot-pounds. Don't forget to install your washer underneath the nut first. Make sure the back of the wheel is clean and flat. No gristle on the center part. And stick it on the wheel bearing flange. And tighten the lug nuts down to 140 foot-pounds. I used a crisscross pattern. 1, 2, 3, 4, 5, 6. And the spec on there, and the wheels true. Take it for a little drive. Make sure the ABS is working. You don't have any light on, and you don't have any weird things happening. Make sure you got a brake pedal before you put it in gear, and that should fix it up.